Hello, everybody. Welcome to Houdini Hangout. We are in December. Thanks for joining us tonight. My name's Peter. Thanks for being here. Hopefully, this will be an interesting evening. We've got some ideas for how to tackle this tonight. And if you didn't see the announcement, we're going to be doing a little bit of Vex stuff tonight. So we're going to try to tackle a VEXember prompt, basically, that we got from are we going to be learning Vex? Well, I mean, yes, hopefully you'll learn some Vex, but if you don't know Vex at all, probably this might be a little deeper for you than you might want, but I'll do my best to explain what's going on, and as usual, and talk through it and stuff like that. Welcome to the stream, Sprawa. Welcome. So the idea today is, like I said, we're going to be doing something from the CG Wiki Discord. I believe if you are a patron of the CG Wiki, you can get access to it and check out what's going on over there. And Stefan Walsh put together kind of a cool prompt for the first challenge, I guess. I think they're going to be doing them like every 4 days or so. And so there's been a lot of activity over there, and maybe I feel like I've seen some people post it on social and things like that. So there's some cool stuff going on over there. And so we're going to try our best to see if I can come up with something, and maybe while you're all yelling at me to close brackets and put semicolons and things like that, maybe we can all together come up with something pretty cool. This is similar to some ideas that people have done in the past. I think last year they did one every single day in December, and that was, I think, pretty crazy. I actually didn't participate in it for whatever reason. I don't even remember why or whatever, but that was this year. I think they wanted to go a little bit more chill with it and just try to, not burn everybody out in the first week on trying to, figure out the Vex code or whatever. So that's the idea. That's what we're going to play with tonight. I figured it'd be, I saw some of it online. I was like, that'd be a fun thing to do on the stream. So chatted with Stefan and asked him if it was cool if I did that on the stream, and he graciously said yes. So that's cool. I know there's he was saying like don't check, don't grab other people's hips and just kind of post them as your own or whatever. But in this case, we're basically to the end of the four-ish days anyways. So I don't think you're gonna seem like you're that much of a Vex ninja or whatever if you do grab my file and post it, because it's like, well, it's basically they're on to the next one probably pretty soon. So so that's the idea for this evening. We're going to be doing that, and if you know Vex, hopefully this will be something fun to like get your brain juices going and figure out a challenge or whatever. If you don't know Vex, this might be a little over your head, hopefully not too much. But I'll do my best to kind of keep everybody on track and kind of going along here. But the one thing I always say before any of these streams is that if you're confused about something, if you aren't sure of, a question or, or something that was done and why that worked or whatever, feel free to drop that in the chat. This is certainly an open place for questions about Houdini. Not going to be, kind of pushing you to the side. If you ask a question that you might feel isn't, that like, great of a question or whatever, but you're confused about something, feel free to ask it here. This is an open space for that type of thing. If you have comments, thoughts, anything about how I should be doing something better, that's great. In this case, I have like normally I don't have very much totally planned out. In this case, I have basically nothing planned out because I just saw the prompt and I'm like, well, I might as well give it a shot live. So This could be a good one. It could be a terrible one. I don't know. We'll see. But yeah, hopefully you'll get a little glimpse into someone else's troubleshooting and how to go about doing that type of stuff. So if you have thoughts or better ways of doing things, feel free to drop them in the chat. Sprawa, you're asking a question. Can I ask what other languages you know except Vex? Is Vex harder or easier than other languages in your opinion? So I don't know many programming languages, to be completely honest. I first started doing a little bit of coding type stuff with After Effects expressions. That was the first place I'd ever really gotten into it. I feel like I might have done a little bit in C4D, but very little, not a lot. And then Houdini was the first place that I was ever really introduced to the idea of programming and coding, on an actual practical level. There's practical stuff you can do with Cinema 4D, After Effects, but it's pretty light duty stuff, just a few lines here or there. So Vex was really my first introduction to proper programming and proper coding. And I've done a little bit of Python as well now. I find that I like the more rigid structure, like the more like hard defined way of doing things in Vex a little bit better for me mentally, because sometimes I feel like Python can be a little bit more flexible than I expect it to be. And so that often gets me very not confused, but just can take me a little bit of time to get my brain around that kind of stuff. So that can be a little tricky for me. Also, just the object-oriented nature of Python is a little different for me personally, mostly because I learned Vex first. It makes sense, but it just sometimes I forget exactly what I'm doing there. Some, things like that. Excuse me, pardon me. Sorry about that. Huge yawn just came up. So for me, I find Vex to be really a comfortable place to be, but it definitely is a lot more rigid than, oh, hey, there's Stefan. Important aspect to understand about Vex over Python is parallel nature. Right. So exactly. That is that's a great point to put out there, Stefan. Yeah. It's so you're taking this code, like you said, and you're running it over the entire set of, elements in your geometry, whether that's points, vertices, primitives, whatever. You're running it over everything in parallel. And so that makes it quite a bit faster. I've seen some examples of people doing things with, geometric manipulations in Houdini with Python and Vex, and the speed difference is crazy. It's like astronomically different. Python has its place, I think, a little bit more in the in some of the API kind of interface stuff in Houdini a bit more. It's not really for manipulating geometry. You can do it. It's just, I don't think it's clearly not as powerful. And Vex is just much more low level, has a lot more performance than Python. But yeah, so that's kind of where I come from. Definitely I know like how to read some HTML and read, some of that type of thing, web-based stuff, things like that. But I'm not like a big programmer, so I don't know a ton of programming languages. So yeah, there's where I come from. So hopefully that'll encourage you that you don't have to be this like master programmer to know how to eventually get into Vex. And it's nice because we have VOPs as well, and that's a nice intermediate kind of place to work on even some of your Vex skills, because it's a visual representation of Vex, right? So sometimes even just like dabbling in there and kind of like getting something, built in that environment can be a nice place to do something. And then, maybe when you build something larger, you go into Vex, but as just like a little playground, you can use VOPs in a very similar way and with similar logic. But when you get into for loops and multiple if statements and things like that, I find Vex to actually be much easier to deal with than all these blocks in VOPs. It can get really, really overly complicated, I think. Hey, Epoxia, welcome to the stream. Yeah, so with all of that said, I guess we should let's jump in and actually do some Houdini. And yeah, if you have any more questions about that type of stuff, happy to stop and answer at any point. But yeah, let's go do some Houdini. So let's first take a look at what it is that we're going to try to make here. So, okay, perfect. That did hold its spot. So here was the post over in the CG Wiki Discord server. And so this is what we're going to try to make here. Oh, shoot. I don't have my chat now. Because usually it's Discord for that. All right, hold on one second. Just going to pull up my chat real quick here. Sorry. There we go. Okay, I got us now. We're good. We're back. All right. So we have, hello guys. Hello everybody. Gabriel, Zach, welcome. All right. So this is what Stefan, hopefully I'm saying your name right there. I just know you as S. Walsh on here. So anyways, so for the first one, what we're going to do is we're going to make something like this little animation here. So we're going to have this little kind of sections where it's deforming up like that. And we could certainly do that with a texture. It looks like we have a bunch of individual spheres that are getting stretched around. It looks like little spherical geometry is kind of getting pushed around here. So yeah, so I think we're going to take a look at this. Maybe we'll first start messing around with this with just the points, and then maybe we can look at it as like as a mesh or something like that and continue to go from there. Cool. All right. So that is the thing that we're going to try to make. So we'll maybe refer back to that a few times, but just something we'll kind of keep that keep that in our side, our little off to the side here. Cool. Great. All right. Let me put me back to something I'm familiar with. Here we go. All right. So what do we want to start with? So let's first, okay. So let's grab geometry object, drop that down, and we will say, VEXember 01. Cool. There's our geometry object. Let's come in here and, I mean, we can do this a few different ways. We could do this with a circle. We could do it with points. Maybe some sort of like a circle would actually make more sense to do it with actual geometry. That way we're not dealing with having to like rebuild it if we want to do something like that. So let's do that. Let's do a maybe we'll just do a planar patch. Actually, that might work. So we could just do this and get a nice kind of circle. So we'll do this on the XZ plane with a circle, something like that. And sure, we can do that. Maybe we'll just set it to 2. Just give ourselves a little bit more space here, something like that. And then let's see here. Let's change our edge lengths a little bit so we get a little bit more geometry. Oh, we can go probably much more dense than that. Let's try something like this. Oh yeah, that's a lot. Maybe we'll just change this a little bit. Hey, axes. Welcome. Yeah, everybody, I'm doing well over here. Just got my first snow of the year, so things are a little white here right now, but doing pretty good. Um, okay, so let's see here. Just trying to think if there's anything I want to do as we're creating this in a little bit of a better way. Okay, cool. So there's our planar patch. The reason I'm doing that is just to get some nice, geometry that's kind of got that randomy kind of effect to it instead of something that's just a regular type of grid. I think this will make it a little bit more interesting to work with. You could also do this similarly by doing a circle, polygon, and this might actually be faster. I don't know. We'll see. Let's see here. Let's do something like, I don't know, 48 on that. And then we could do a remesh here. Free tutorial. Well, I mean, they are tutorials, so go to town if you want to. Yeah, that's actually maybe a little faster. We'll give this a little more iterations, maybe something like 5 and do 2 smoothing. Yeah, that actually seems to be a little faster. We'll go that way. We'll go that way instead. So we'll do the circle with the remesh. And then I think if we go to 0.01 there, yeah, that's pretty smooth. And just remember that if you want to get these edges more rounded, you could always do something like that, 96, and just get more edges there. And there you go. Okay, so that's maybe a little bit faster to deal with. We'll go back. Maybe we'll just keep it at 0.02 for right now. Okay, so the first thing I think we want to do is, so we're dealing with, let me see here. Actually, could I do this? Here, can I do that? Yeah, open in browser. That's what I want. Okay, much better. Get a much nicer image of this here. Okay. So we've got this here and we want to set, some points that are going to get pushed up like this, right? And have them, have this kind of deformation going on with this grid. So let's maybe first select which points we're going to do that with. I think that might be a good starting point here. So let's do that. Let's see. Let's do a let's do a point wrangle. Drop that down. So the first thing that we're going to want to do here is we're going to want to figure out, maybe let's just find one point first and see how we can kind of make some of this stuff work, right? Before we go too crazy with this. And I'll just define which point I want to use. What? Oh God. Yep. Okay. So let's see here. Let's take this. Let's do int. Just make an integer thing and say current point. And we'll set this equal to, set this equal to one of those middle points there. Just grab one of these real quick. Let's do 2751. Easy enough. So we'll do that. 2751. That's going to be the current point that we're going to be dealing with. Whenever you have an error here, it's not going to actually, execute it, right? So if you have an error in your code, it's going to throw an error here and it won't show anything. That's why it was giving me that weird little issue there. Hey everybody, welcome. So we've got these points here that we're gonna have points that we're gonna select, but for now we'll just start with one. And what we can, so we're just hard coding that for right now, just maybe to play around with this and see kind of what we can do here. So we can do a distance here, right? And we can do oh, cool. Okay, cool, Tom. Yeah, I think I did upload it. Yeah, let me know if it's still not there. Maybe I just forgot to do that. So, Good morning. Wow. You must be in a much different time zone than me. Welcome. Welcome, Chris. Nice to have you. Okay, so what we can do is we can calculate the distance from each current point, right? That's what we're operating over to this current point here, right? And so that distance will give us values that we can work with. So let's calculate, let's first grab the, let's maybe call this active point instead. And then we can say vector. So we're going to get another variable here that we're going to create a vector. And let's find out what that position of that point is, right? So we're going to say active pos. So it'll be active position. And we're going to do a point. We're going to use the point function here. And this is, we can take a point attribute from the geometry. So this is going to be for each iteration, we're going to be using the same point number. So we can kind of do that for right now and just use that same value to be able to to compare that position to each of the current positions here. So all right, so we're going to be doing the point function. Whenever you're doing this in Vex, you can see when you get to the first open parentheses, you can get a little help card here that'll show what this is going to be looking for. It's going to be looking for geometry number, basically. Which stream of geometry are we looking at? In this case, it'll be 0 because it's the first input. Then we're going to look for the attribute name, which is going to be P for position, and then the point number. And the point number is going to be this active point. So what we can do here is we're going to say 0, and then we're going to do in quotes P, and then, let me make that a little bigger too so you can see it. And then we're going to do active point like that. Oops. And that should give us the current position, the active position that we're looking for of, whatever number we're looking at. And then what we can do is we can actually calculate a distance here, right? So this is going to be the distance between 2 points. So we can do the current one, which is going to be V at P. And then the second one was going to be the active pos like that. And let's say, let's call this, because it's going to be for each point, we're going to call it my dist. And this will be a float. Float my dist equals. All right, so now what we're doing here is we're taking, I capitalized that. Sorry. Okay, so now we're taking this float, putting in, creating a my dist float that's going to have the distance here. And what we can do next is we can actually write this out. So we can say f at, we'll just call this dist equals my dist. And now we should have a distance attribute to that point, right? To that point position. And itself is going to have a position, a distance of 0, obviously. So now let's just resort this back here. If we wanted to, we can come in, click our little eye here, and we can click this on to change the visualization of this. And you can see that we're getting a fall off around this point. And so we could change this too, right? We could say, how many points? We have 8,000. We could say, just change this to 2651. And that's going to move it where it is, right? So this is a way to be able to basically get a certain fall off to this position, right? And so what we're going to do then is we can basically deform this based on that, right? So let's do a couple other things here. So let's maybe make this a little bit cleaner. So let's call this, I'm just going to make a little comment here and call it, we'll call this, I often call this like my setup. And then maybe down here, we'll say functions. And then down here, we'll just call this maybe like output, something like that. We can always make other comments and things like that because we're going to do probably a decent amount of stuff here. Maybe not just in this one wrangle, but we'll probably use a few wrangles to do some of this stuff. But so yeah, so we can set this back to 2751, so it's a bit more in the middle here. So there we go. We've got a we've got a distance that we can then work with, right? This is going to be a linear distance that we could remap to do some of those interesting kind of, things that we're pushing up there, right? So we've got our current active point. We've got the position of that active point. And then down here, we're calculating the my distance here. And let's maybe in here add a something to remap this a little bit. So let's say, let me just think of the best way to do this. So let's see here. We can say float my dist equals, and then we can do a ch ramp, right? And this is going to basically give us a ramp parameter. This is going to be building a parameter for us. And we're going to feed that previous distance through this and then get a remapped value out of it. And so we're going to name this something like, let's see, what can we call this? We'll call this displacement ramp. Like that. And then this is going to be, let me just pull this up actually really quick. Pull up my help. I just want to make sure I'm thinking of this correctly. Also, if you put your cursor right after the name of a function and hit F1, it'll bring it up for you. So here we're looking at a channel, and then we want to look at the ramp position here that we're going to be reading in. So let's do that with this my dist. All right. Well, let's see if we can get this doing something here. Oh, right. Sorry, I don't have to declare that. I think I can just say my dist. Oops. There we go. So here we can now, we've already declared this, right? This my distance. And in fact, what maybe we would do instead is there's a different way that you kind of go about this. Is you could say up here, we could actually set this up and say float and then call out my dist here. And that'll be the same, right? You can just define these as a float variables and then do this kind of stuff here where we take the distance, calculate it, and then throw it through a ramp, basically. And another thing we want to do is press that button there, right? In order to make a displacement ramp from this. And now we've got our displacement ramp. This gives us its name. That's where this comes from, right? So that's the name. And then my distance is what we're using here. And so now you can look and see here, we can actually adjust this, right? We can take this ramp, and now we have something that hey Brian, welcome. Yeah, glad you could catch us. Well, welcome to the stream. And so now we have something that's going to be able to actually kind of control this a bit easier. Oh, the VEXtension. Yeah, I don't know. That one. I'm not even sure of how to even think about it. Maybe I will. Maybe I'll try it out. I don't know. We'll see. VEXpansion. There you go. VEXtension. That's a pretty good one too. VEXtension. That's great. Very cool. Proud of myself. That's exactly what I mentioned would happen. Oh, you mean? Do you mean because of the Joy of Vex stuff? Is that what you mean, La Pampadura? Hopefully, I don't know if you're referring to stuff I did, my courses. I don't know who my thing is, but yeah, anyways. Okay, so we've got this ramp here, and this is going to be controlling this attribute. Now, we are capping the distance at 1 there, and it's going to 0 in the center. Oh, cool, La Pampadura. I'm glad. Yeah. James, that's pretty clever one though, VEXtension. It's close. It's nice. I like that too. All right, so what we could do here is we could do this maybe. Yeah, that should flip it. And so now what we could do is we could give it the opposite, right? So now everything's going to be getting 0 except for this little area that we define here, right? And so we're starting to get somewhere with this, right? We're starting to do something that's going to give us that deformation that we want. So, okay, so now we've got this attribute, right? Our distance attribute. We could also call this mask. We could call this a bunch of other things, right? In fact, we don't even have to write this out. I'm just going to write it out for my own sake here. just so we can see it and actually work with it, right? Because we can only really visualize attributes, right? We can't visualize variables. And just if you're kind of not sure what the difference is there, when we declare things like this in here, these are variables, right? This is a my distance variable. And this here is a distance attribute. We're saying this is a float attribute at dist. So that's how we write an attribute, how we export attributes from here. And the best way to think about why you would use one versus the other is if you want something to travel down your chain of nodes, that's where you would do something like an attribute. If you want something that's only going to be calculated in that one wrangle, then you can just do it as a variable. If you're not going to write it out to the points, better to do that as a variable. And it's in a case like this where we have 8,500 points, writing out attributes is not a big deal. But when you talk about something that has 10 million points, like in a real production environment, writing out extraneous attributes actually takes up a lot of data on disk, especially if you're writing it out or RAM or things like that. So just something to keep in mind that in some of these small use cases, you can kind of write all the attributes out you'd want. But when you get to like more of a production case, you might want to be a bit more careful about those types of things. So anyways, just a little thing to think about there. So, you know what, maybe we'll do this in separate steps. Instead of having like one monolithic, wrangle, I actually think that might be a little bit more, hard to kind of wrap your head completely around it. So maybe we'll do this in multiple wrangles, and we can name them then that way. So let's say this one's going to be our calculate distance to active point, like that. So this is going to be calculate distance to active point, and we can have multiple active points, and we'll come back and maybe manipulate this in a second, because that's really what we're doing there, right? We're doing a bunch of these things, we're doing this all, we want to do this on maybe multiple points here in this case. So let me just pull this over here. Actually, sorry. Just kind of rearranging my windows a little bit here just to get it a little bit better. Okay, cool. Wow, there's a lot of emojis happening here now. That's great. I love it. Anyways, okay, so we've got our distance. So let's now take this and do some displacement with these values, right? So let's adjust this a little bit. And actually, let's just maybe do this, and we'll change this over to maybe a B-spline would be good. And we can just kind of add a couple things in here to just make this a little bit interesting, like that. Sure, we can get something like that. Cool. Okay, so now we've got a little bit of a curve going on there. And this will be able to be something that we can actually adjust over time, depending on how we want to do this. So, cool. So let's now do our displacement. Let's do that. Oops. So let's do a point wrangle. And we're going to just do the displacement here. So let's say create displacement like that. All right, so this next one is going to be a point, we're going to be working on the points and pushing them in a certain direction. Another thing to keep in mind here too is that whenever you put down a point wrangle, primitive wrangle, blah, 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 it's just using an attribute wrangle and telling it which one to run over. So we're looking at points, primitives, vertices. So you can do it a certain number of times, or you can do it over the entire detail, which is just once, basically. Which is basically over the entire geometry. Now that just means that it only fires once. It's not actually running over the entire geometry. So it's kind of a little bit of a special case where you might want to just have something run once. And there's certainly times when that makes sense. But in this case, we're running it over points. So that's what happens when you do so say I did like a prim wrangle. It's the same thing. It still says attribute wrangle, but here it says run over primitives. And a standard attribute wrangle will by default run over points. So just little things to keep in mind there. All right. So for this one, let's do a little setup here. Try to be as clean as I can so people can look back at this and understand what the heck I did. All right, so let's say we're going to make a vector up. Let's this is going to be the direction that we want this this displacement to go in, right? So let's do that. We'll set this equal to we'll just make a channel CHV because we want a vector channel. So we'll say CHV and we're just going to say what the name of the channel is going to be, and we'll just say displacement direction, like so. And then if we press this button, we should now have a displacement direction that we can use. In this case, we'll just start with 0, 1, 0, but you'll be able to see that we could manipulate that a little bit. We could also do a random displacement direction on the points, like across the whole thing. So in different areas, like you could have them displace, away from the center or something, something like that. You could do some different things with it. And you could have them displace differently over time. So as they displace more, they might bend in certain directions. So there's a lot of different things you can do there. But in this case, we'll just start with it going up just to make it really simple. So we've got our vector up here, or we could also call this vector maybe direction instead. That might be a more, a more accurate name for it. So we've got our direction. Let's also do a float. We'll call this maybe disp scale, something like that. And maybe I'll call this displacement direction, like that, and then displacement scale, and we'll just do CH. By default, that's a float, and we'll call this exactly like it was there, displacement scale. The reason I do the underscore is because I don't think it likes to have spaces, and that will automatically give us a space for it. So there we go. So there's our displacement scale. Maybe we'll set that to 1 for right now. Cool. And then if we come down here and we'll just say functions, then we can do, this should be pretty straightforward. What we can do is we can set our v at p like this, and we can say plus equals, right? So we're taking our vector position. We can add a vector to that. So let's say we're going to add the displacement direction to it. And then if we just do this, it's going to should displace the whole thing. Displacement direction 0.1. What did I miss there? I missed something. What did I do wrong? Let me just see here. V at P plus equals. I'm just gonna hard code this just to see what I'm missing here, because I'm missing something. Oh, display flag. Display flag. Everybody's yelling at me. There we go. Duh. Yep, there it is, the display flag. I'll get there eventually. Anyways, yeah, so we've got our displacement direction like this now, right? And so this will allow us to be able to say what direction we want it to go in. We can also then take this and maybe just, actually, I think I can just do it this way. I don't think it's going to be like an order of operations issue. So then we can just say times displacement scale capital. There we go. All right. So now we should be able to adjust this here, right? So we've got our direction, we've got our scale. Now the other thing we need to obviously put into this is the distance. So let's do this as well. So let's say we'll make a float. We'll say float mask, and we'll set this equal to f at distance, right? So this is going to be like our mask value, right, that we're going to mask this against. So let's do this. We'll first multiply those together like that, and then we'll multiply it by the mask value. And now we should have one kind of protrusion up here that's going to be defined by this mask, or this the distance that we calculated there, right? So if we come back over here and play around with this, we'll see that this is going to change the way that this is kind of calculated and defined. The other thing that you could do here as well is you could do we could add one more step in here where we would do like a fit on this. And let's see here. How would we do that? Because right now, for example, we have, gosh, I think this goes well past 1. And so what we could do is we could say, we could set a minimum, like an upper and lower limit for this. So we could do something like this and say my dist equals, and then do fit, and then give it my dist here, set this to, we could do 0, 1. You could do something like this. Let's just set this up real quick. And then we could say, we could do it like this and say 0.25, something like that, right? And now we're going to have this whole area that we can work with. So we don't have to be quite so cutesy with it just being down at that very low end of it, right? We could manipulate this and do kind of fit this ramp here to whatever scale we're working with, right? So we could then keep that ramp the entire width of it and not have to replace that. The other thing we could then do as well is we could say, we could add some variables for that, right? So, or a variable at least for the maximum of it, right? Because we know the minimum we want it to be 0, but the maximum, we could say something like this: float max dist, something like this, equals, and then we could say ch and say max distance. Yep, that's true as well. That's a great point. First garden, yep. Yeah, so if you're working with a set range, you can type in here, we can say fit. You can see there's fit 0, 1, there's fit 1, 0, and there's fit 1, 1. So fit 0, 1 goes, starts these first two values here. So basically what we're doing when we're doing a fit is we're taking this float value here, in this case, my distance. We're saying, okay, give me let's take this. This is the low incoming value, and this is the high incoming value, right? So we're going to clamp it at either of these, right? There's a way to do this with a e-fit, but with this fit, it's clamped. So it's clamped between 0 and 0.5, and let's remap those values now on the low end to 0 and on the high end to 1. So if you do fit 0, 1, that's going to automatically set this to 0 and this to 1, right? If you do fit 1, 0, that's going to put this at 1 and this at 0. And then fit 1, 1 is going to set this first one to -1 and the second one to 1. So those are some different ranges that you can have by default. So that's what First Garden is mentioning there. And yeah, it's really helpful. I use fit 0, 1 a lot because that's kind of like a normalized range. So if you know that you're getting a 0 to 1 range, you can just write that down and you don't have to write it into the thing. In this case, we want to adjust that incoming range, and the outcoming range is how we want this to be normalized. So let's do that. So now we have a max distance here, and we can set this to whatever we want to set it to. And we can say here, max dist. And now we have another attribute or another parameter here that will let us control this. And this is kind of really nice because now we're able to set a maximum distance and have this ramp kind of fit to whatever distance we're looking at, right? Because we're taking this, now we're taking, just some random number, 0.754 is the maximum distance, and fitting this ramp across it. So now when we come down here to our create displacement, we're going to see that, we're going to see that range be kind of represented there. And we can really easily kind of control this without having to come in here and really mess around with this ramp, right? Because we might have a lot of points to this, right? You might have a point over here that you want to mess with, and here, maybe something like that, right? So you kind of can play around with this now, and no matter what you do there, now your distance is going to be able to kind of stay locked in that range that we're looking at. So it might be a little bit of a better way to do that. Okay, so we have these values working now. Let's see if we can't. Let's see if we can't figure something out here. Okay, let's see if we can animate this. And I'm just trying to think of the best way to do this. So, okay. So I think what we're actually going to do is maybe even put another value or another wrangle in here possibly, to try to get some better, to maybe be able to control this a little bit better, right? Because, what we're actually doing here is we're calculating the distance, right? And that we're using for the fall off. But what we probably want to do is use those individual points to control how much displacement we're going to have, right? So the displacement scale itself. So we could actually have this displacement scale, instead of being written by this value here, we could pass an attribute down, right? And so what we really are probably going to want to do here is have is calculate that over time, calculate that to be able to kind of move across time. And so what we could then do in this step here, where we're calculating this distance to the active point, we could actually pull in the active, like the active points displacement scale, and pass that to all of the points that are within this certain range, right? We could have a distance threshold where that would get passed along to it. And so, well, we could do that at a bunch of places, actually. We could probably do that down here as well. So it really, just trying to think of what. Obviously gets quite a bit more complicated when we're dealing with multiple points, right? That we're trying to calculate distances to. And yeah, no problem, First Garden. Well, glad to have you. Nice to see you in the chat. And yeah, have a good one. So let's think about this. All right. So instead of just calculating one point, let's get a whole bunch of points, right? Because then we could probably start to actually think about some of these values a little bit easier. There's just so many different ways you could go about doing this that it's kind of like my brain is a little swimmy right now. Yeah, coding is actually pretty fun, honestly. It's cool, like especially when you get to some of these things, right? Like you can do some really fun stuff. Okay, so let's do this. Let's just do another point wrangle here. I think this will give us what we want, and we can do we're going to do some animation with this. So I'm just trying to think of exactly how I want to pass this through in a smart way. Maybe maybe I'll just hard code this for right now and think about how I want to pass this exactly, because we're going to use this same thing here. So let's just do this for right now. So we're just going to grab the same thing here. We're going to have active point 2751, and okay, so the next thing that we're going to do is let's get a let's say give it a start frame. Let's give it 10 maybe on that, or let's do it in something a bit more round. Let's do 12, and then we'll do let's do 36 here. I'm just gonna didn't put a semicolon there. All right, so there we go. The other thing I'm going to do is make this a little bit shorter. So let's make this, I don't know, 72 for right now, just so we can loop over this a little bit easier. All right, so we've got an active point, start frame, and end frame. Let's take, this will be our functions. Let's do, yes, that is a good point. Yes. So what we could do too, if we wanted to do this in a separate stream, like Stefan's talking about, we could have a separate group of points that we would actually manipulate and do some stuff on. So that is another way we could do it as well. That's fair. We could give that a shot and see where we go with that. So so what we could do there is we could scatter it. We could scatter some points. That's very common. And we could do just like 10 points here. Let's maybe turn the relax iterations down a little bit, something like that. Might be a little hard to see. Let me do this and change my, let's do 3 here. That's not the right one. Let's do this at, I always like around 6 personally. So we'll do 6 for both of those. Cool. All right. So we've got some points, and what we could do there is we could we could do this. Oops. We could do this same thing here. Over here, maybe instead. And what we can do with this, so we could do this like quite a few different ways here. So let's take this in, and instead of our active position being this 0.0, what we could do is we could just say 0.1 instead. That's going to go to the second input, like so. And then we could just say here instead, we could just say the 0th point, which would be here, right there. So it'd be 0. So we could do that instead. Oh, hello. So we could do that instead. In fact, I think you can, oops, you can, nope, not in those you can't, sorry. Okay, so we could do that, and then that would be a way that we'd be able to have the points reading out. We wouldn't even have to set up this point like that. There we go. There's our start frame and end frame. You could also do those as channels as well. So we could say ch start frame. And then I'm just going to copy and paste this. And call this end frame. Oh, duh. Sorry. I'm just going to undo a couple there because what it's yelling at me about here is that there's an implicit cast happening. So I'm going to say chi instead here for both of these because that is going to be an integer. And now it's not going to be as angry here because we were actually creating integer values instead of having a float cast to a integer, which just can be messy sometimes. All right, so we'll set these to 12 and 36. This could just make it a little easier for us to be able to deal with. And if you wanted to change how long these are, like how much width of those there are, you can come in here. You can actually get start frame and end frame. You see them right here, these generated channel parameters. And we could come down here and just give it like the whole width of this and say 240. Like that. Apply, accept. And now these are quite a bit longer and we can have a bit more function out of that. So the other thing we're going to do is we're going to make another ramp here that'll control how this goes up and down basically. And I think that'll be kind of nice. And what we're going to do here is we're going to do we're going to call this displace maybe. Let's see here. We're just going to call this float displace. So we're just going to call this first and just set this up. There we go. So what we want to do is we want to take this displace attribute and look at it over time maybe and give it the ability to basically have these go up and down, right? At different values basically. So maybe the easier thing here to do would be to, instead of giving it a start and an end frame, as I'm thinking about this, maybe it would be easier to say, give it a start frame and then a length, because we could randomize both of those things and get some interesting results from it. So let's try that actually. So, yeah, let's do that. So I'm just going to go back into this parameter interface. I'm just going to get rid of the end frame here. I'm just going to delete that and hit apply. Cool. And I'm going to call this frame length. And we'll say this is going to be frame length, something like that. And then we're giving it displace. Cool. This is going to be the length of frame. So maybe we'll just say it's going to be, give it 1 second for right now. So it's going to be 24 frames. It's going to start on frame 12. And then we can do we're going to do a fit function here. So we're going to say displace is equal to fit. We're going to fit this between the start frame and then the start frame plus the length, right? So that'll be the end frame. So let's do this. So we're going to fit time, or we're going to fit the frame. So we're going to say at frame. This is a built-in attribute that we can use. So you do capital F frame, and then we're going to do, then next we'll do start frame like that. Then we'll do start frame plus frame length, like so. And then, oops, that's a comma. And then we'll do 0, 1. I'm going to make this a little bit smaller so you can see it. Or maybe actually just make this a little bit wider so you can see it. So that's going to be the function that we're going to be working with. So we're going to be fitting frame but to the start frame and the frame length and 0 and 1. So this is basically taking that value and normalizing it, right? So now this displacement value is being fit across time, and we are going to be using that to then control how we want this thing to displace over time. This is basically procedural animation. I like working this way. I think it's kind of fun. Gives you a neat little way to do, to kind of control these things a bit more. There's a bit more customizable, I think, to be able to do some of this stuff. You can get some really nice results out of it. So we've got that. And then we're going to say, so now that we've got this normalized kind of displace value, let's say we're just going to set this equal to, and then we're going to do a ch ramp. We're going to do another ramp. We're going to call this one maybe displacement anim, something like that. And we're going to use displace again for this. And then if we do this, now this curve is going to be over time how this is going to go up and down. So I want this to kind of go, maybe I'll have it shoot up a little quicker and then kind of fall off over time. And so I think what'll actually be easier to do here now that we're doing this separate in a separate channel like this, or a separate stream, I think it will actually be easier to put these two together. So let's do that. I'm just going to cut and paste this stuff over here because this really is all going to be pretty flexible. So I'm just going to hit plus here. This displacement direction is going to be 1. And the scale was, what did we have it at 1? Yep, that sounds right. We had it at 1. Okie doke. And then really all we have to do is cut this out, and we're going to put this down here for the output. And what did I miss there? I missed something. Sorry, just going to undo what I did there for a second, just because I cut and paste. I should have copied and pasted. So I had it here as well. All right, so let's see. What did I do there? Oh, I know why. Because we're not actually writing this distance thing yet. So it's actually asking for f at distance up here. And that's not going to work at this point. So this we can just get rid of. So let's take this. We're going to move it down here first of all. And instead of, we could call it mask. Instead of, we could just call it that way and say my dist. We could just change that over to mask. Yeah, that's fine. We could do that. And then we could just copy and paste this over here. This isn't going to be the cleanest thing in the world, but it'll be fine. It should work. Okay, now I need to make those. Set this. Oop, that's too far. Yeah, there we go. Cool. Now it's doing it. Okay, great. So now we're getting back to where we were. And the cool thing I think that we're going to be able to do now is, instead of having this displacement scale here as the channel displacement scale, what we can do is we can actually read in this here. We can just get another thing here and say output. And this is where we need to actually put an output in this, right? We need to, or actually output an attribute, right? So here we're going to say, let's do f at displace equals displace, our variable. So now we have a displacement amount. And if we watch that, we should see that it goes up and down. And what we can do here is we can actually watch this and see some of this happen here. So let's visualize that. So let's come in here. Let's visualize displacement. We should see that this one is going to go, they're all going to go up and then back down. Now, the reason for that is that they all have the same start frame, right? So you can see there, whoop, and then back down, right? Back down. Okay. So now if we do that here, and instead of getting this displacement scale, we can look at the, we can read that in and use that. So let's do that. Let's see here. So we're going to just call that point. So this, we can use this function right here. It's the same exact function. So let's grab this. And instead of P, we're going to look at displace, and we're going to use 0.0. And now we have this displacement scale. So now as we hit play here, that's going to go up and back down like that, right? So we're going to have it go up and down. And that's being controlled by this right here. So if we click all of these, do this as a B-spline, something like that, we get a little, you know, a little animation there. We can kind of play around with this, get this to do something that, you know, we want it to, however we may want it to, right? So we can do that. It actually doesn't love to, you know, doesn't love grabbing these when you do it like that. So let's see here. And then we could do this 36 frames and it's going to boom and then be longer, right? We could do it 64 frames. There you go. So this is going to be completely variable, right? So that's cool. So now we're getting that to work. And let's see if we can't now make all of these points react to that, right? So, so instead of saying we have this active point of 0, this here, when we're looking for this active position, that's going to be the position of the nearest point, right? And in this case, we're looking at the nearest point on this second input, which is here. I'm actually going to template that because then you can look at it and see it that way. Might be a little clearer. So instead of just saying, let's just look at 0, and that's the active point, maybe what we do here is we set up a new active point. And here what we can say is int active point equals, and we can say near point. And this is going to give us the nearest point on this other geometry. So if we say 1, that's going to give us the nearest point to this second input, right? 0 is the first input, 1 is the second input. I know it's a little weird, but that's the kind of computer science-y world where computers start at 0 for their inputs, but we like to say first input. We don't like to say the 0th input. So it's kind of the difference between computers and human speak there. So let's do that. So that's the geometry that we're looking for. And then we're going to be using what position, which we're just going to use the point position. So V at P is the current point's position. So let's do that. And let's just give this a play. I'm kind of curious if this is going to read them all. Right. Well, we're not telling anything to do that yet. So, okay. So that's why. So we've got this one and we need to now put that in there. So let's copy and paste active point and put this over here and down here as well. And there we go. Now we've got these all kind of shooting up in the air like that. And that's kind of working just fine. Now, what we could do as well is so that they're not all starting at the same frame. What if we gave it a random number to go with, right? So what if we set, instead of this start frame from this, what if we set this, you know, some sort of random value here? So let's do random. Yep. So let's do this random, and then we can say, so this is going to create a random number between 0 and 1 from a seed value. So let's use our seed value as point num. So that's the current point number, right? So now we have this random value here that is a point number. This is going to get a little funky here because it's saying that this is now a float and we're trying to write an integer here. So let's do this. Let's take that random value And now what we could do is we could use one of those fit values, that fit 0, 1 that we were talking about before, right? We know we're going to get a value between 0 and 1. So we can fit these values between 0 and 1. So let's say fit 0, 1, this random point number, that's the value that we want to fit to some other range. So now let's fit this to some other different range. We can say 0 to, I don't know, we'll just say 36 right now. And what we could actually do is we could, instead of have just a start frame here, we could have a maybe like a max start. So that would be, we could have a minimum and a maximum start frame value, right? That those could be set between. For right now, we can just hard code this between 0 and 36. And so now we have a start frame that's there. Let's do, I think if we do r int, this will round it to the closest whole number. Is that going to be happy? No, it's not happy about that because it's doing it that way. So I think if we do this, if we do integer like this, I think now it'll be happy because we rounded it, but it was still a float value. And now we set it to an absolute integer value, and that should be much happier now. So let's take a look at this. Let's just watch this value here because we're still visualizing displacement. So let's see if this works. Yep, looks like it did. Boop, 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 boop. Cool. Let's change this to like 96. Let's come back over here. We can actually get rid of this, and this will be our, maybe I'll just call this create anim src points, like source points, create and animate source points. So now let's take a look at this. Woo, yep. Now we're getting something happening here. Now, the only thing that I'm not super happy about here is that we're calculating this based on just its nearest point. So I'm not super thrilled about that. Let's take a look at this again and see exactly what we've got going on here. Yeah, it does seem quite a bit smoother. I don't see any of that like complete overlap happening there, but we're pretty close. We're pretty close to that. So what we could do here is we could just really randomize this quite a bit more and say, this could go all the way to 72, maybe 72, like that. Now, the problem again is going to be that if we had more of these, we're just going to get these little weird sections, and I don't really love that. So I kind of wonder, Yes, exactly. That's exactly right. Yes, the max distance is less than the diameter of, yeah, exactly. That is 100% true. And what I'm thinking here is that if we did, where was it? Max distance there. Yeah, you can play around with this and make it a little bit cleaner, right? But you are always going to have this little bit of overlap here. That's kind of funky. Not always, but you can get that quite easily depending on how scattered your points are, right? I mean, it's not terrible, but the other thing that you could probably do, I'm just trying to think, is like you could set this up with some sort of an array type situation here. Unless there's a way to smooth that. Just trying to think, just thinking here a little bit. So the other option that we might be able to do here is let's just take a look at this and just maybe the rules about suggestions from chat. Oh, go for it. I mean, hey, the rules are yell at me as much as you'd like. You're more than welcome to say anything you'd like. Well, not anything you'd like. Sorry, I shouldn't say that. You're more than welcome to make comments about this. Oh, that is a good point. That is a very nice, that's a pretty elegant solution, actually. Yes. No, it's totally cool. Yes, output attributes here. Then the radius attribute, there we go. So, yeah, what we could do here there you go. There's the answer right from the source. I purposely avoided overlap. Yep, exactly. Yes, that is a very wise choice to do. Exactly. So we could also do this across multiple points. Just don't have the problem. Easy. Exactly. I like that. Yeah. Sometimes it's smarter to do it that way, right? Okay, so let's take a look at how we would do that with these. Fix, don't do the hard thing. I love it. Okay, so let's look at how we would implement that, right? Because what I just did here is I took the scatter and I had it export this p-scale attribute for us, and that's going to be the scale, sort of the scale of these spheres. It's not exactly, but it's should be pretty close, because you can see that these are kind of within a certain range. But so we still have the p-scale here. We have displace. So now let's take the p-scale value and have that drive this max distance, right? So let's do that. So here we can say, we're going to do the same thing with this point function here. So let's grab that. So we have to rewrite everything every time. And let's just grab p-scale. So now instead of this max distance writing anything, we should have our p-scale writing those values. So let's see here. Yep. And now they won't overlap. So now, no matter how far we go with this, we're just going to get finer and finer points, basically. Because we're changing the p-scale of these based on, how far apart those points are scattered, right? Because the more points we have scattered here, the smaller this p-scale is going to be. See, that goes down. If we go back to 10, this is going to go up to like 3, and so now we're going to have nice big kind of softer looking things. But this displacement ramp is going to still stay the same because we're just now this max distance doesn't do anything, so you could delete that out of there. But we could adjust this here. Whoa, hey, look at that. Let's find a spot where we've got some here. And so yeah, you could certainly adjust these however you'd like to, make them more pointy if you'd like to, have them do some weird stuff. You could do whatever shape you wanted with them. These can actually also go past 0. So we could actually take this, which this is at a very low value right now. We could actually have this go down negative. So you could do something like that if you wanted to, right? And do some like negative-y stuff, some weird stuff like that. And then if we did this at value of 0, yeah, there you go. So now you could get something weird like that where it goes, it's got like a little divot next to it as well. But that's also, it's just kind of weird. You can do that stuff. Just remember these ramps can go past 0 and 1. Not always the most well-known function. Oh, also if you expand these, it gets a little nicer. You can see some numbers and stuff like that to know exactly kind of what values you're putting in here. Yeah, so there you go. We're starting to get somewhere with it. In fact, we're pretty far along with this, right? Like this is definitely doing something. And what we could do here is, let's see. What else could we do with this? Don't really need that anymore. We can get rid of that. So it's kind of crazy. I mean, we've done a lot with just a few nodes here. There's not like crazy amount of stuff going on here, so kind of neat. Can do quite a bit with a few things here. Oh, grabbed the wrong point. Can never remember if there's a better way to do this. Can we do that? Is that better? Yeah, maybe that's actually better. Maybe not having that live parameter display is what causes the issue. Yeah, that's actually a lot happier. That's great. I'm going to maybe keep that off. Okay. Anyways, we've got that working now. Right. Yeah, I'm not sure what else we really want to do with this. I think we're getting pretty close to the example here. In fact, what I'm going to do to make this a little bit nicer is I'm going to change this animation a bit, because what we actually have is more of this, like where we float up and pause for a bit and then kind of come back down. So I'm just going to adjust that a little bit, make that a little nicer. Yeah, there we go. Looking nice. Right. And just another thing to note, that if you changed the global seed here, it's going to change your animation. So you can just change this as much as you want to. Oh, if you wanted them to be different heights, Zach, is that what you're saying? Like have them each be different random heights? Is that what you're saying? Maybe. I'll wait a second for your response. Oh, I see what you're saying. Yeah, I'm not sure. Honestly, I'm not sorry. I'm not sure what those. Yeah, that's interesting. That is a great observation. Yeah, I was kind of not thinking about how that would work. Okay, now do it all in one rank. Technically, you could, I'm sure. Yeah, I actually wasn't. I'm not sure how you try doing it in cops first. Yeah, I'm not sure how you're doing that specifically. That is interesting though. They are random heights, so let's do that first of all. I'm not sure how you do those dots. That actually was confusing me when I saw it at first. I was like, oh, it's the dots that are moving, but then I'm like, no, those are on the geometry. I'm not really sure how you did that. It's pretty weird. If you want to give a hint on that or something, I don't know. I definitely would appreciate. I would definitely take a hint on that. Unless you just did it with a much more solid mesh, and then yeah, maybe it's a much higher resolution mesh that you were doing it with, and then had attributes on the points that were, because that sort of stays still except when it goes up. So yeah, I'm not sure exactly. Anyways, let's scatter this first, and then maybe we can get to that. Okay. So again, we're just working on these points here. So let's add another thing in here and say it's going to be a float. And this is going to be, we're going to say random. We'll say random height. It'll be a little easier maybe to understand. Then we'll do the same thing here. Let's do random pt num. But instead of it just being random pt num, let's give it a little offset there so we can get a little different seed from it. That's going to give us a value between 0 and 1. I don't think we want it to go 0. So let's do another fit 01 here. And let's maybe go between 0.5 and 1. I think that's going to be pretty good. Oh, got to put a comma in there. So let's do between 0.5 and 1. Like so. And then we could actually just do this down here. Do displace times random height. And let's see if that worked. It should have. Let's just double check here. Yep, we're getting some random heights there. If we took this down to 0.25, there we go. We're going to get some, yeah, maybe that's actually better. And the reason I do that offset there is because you don't want the noises to look exactly the same as they do when, you know, you don't want them to look exactly the same. Like, oh, this one goes at this frame and it's only this high. You know what I mean? Like a lot of times you want to put different seeds in there so that your noises get broken up a bit and look a bit nicer, basically. The other thing you might want to do too is you might want to take this and scale it down as well so that these aren't out at the edges. Like if you don't like how those look here where you're getting this, you could just do a transform here because we're basically on the XYZ plane. So we could just scale this down a little bit till those are all inside like so. Then should be okay. None of those will go to the very end like that, the very edge. There you go. So that's another option there too, because basically we're just scaling that down a little bit. In fact, you could scale that down. There's really no reason to be using the remeshed option. And maybe just maybe what we could do here is we could I guess if we had another geometry that we were looking at here, I don't think this is going to slow it down that much now. It's still at 24 frames a second. I'm curious what this is going at though. Like, oh gosh, yeah, it's going like 50. We got plenty of overhead. Just trying to think of exactly what we could do to get that pattern on it. What we could do is we could scatter some more points on this. Could actually use 2 of this same thing. Is there a smarter way to do this? Because I'm just thinking, if we took another scatter here off of this, for example, and let's just go. Yep. Yeah, you could do that. Yeah, because what you could do is you could take this and do the same thing with it, right? No, what am I missing here? Yeah, that does work. I just don't love that it's the same thing. What I probably should do is make a reference copy of that and just it's not really Vex. Yeah. No, I think that's interesting sampling them into cops, yeah. But in the spirit of Vex, let's try this. Let's see if we can do this. I do like that though. That's interesting. Yeah, you could use point to form as well. Yeah, for sure. Okay, so let's do this. Okay, so let's do another point wrangle here and grab both of these. So we've got these points, right, that are kind of moving along with this. Curious exactly here what happened. Yeah, cool. We could scale this down a little bit as well. Maybe not quite as much. Okay, so Stefan's just saying this. There are 2 very Houdini approaches here. One scatters a bunch of points beforehand, then interpolates the mesh animation onto them. The other would be to look at the current mesh post animation and think of a way how we could make points from that. Make points from that. Oh, right. I see what you're saying. A point down for each. Yeah. That is a good question. Yeah, I wasn't sure about that either. Oh, they're discs. Oh, that's interesting. I didn't realize that. Hmm. um, right. Sorry, I'm just thinking here, just thinking. Um, yeah, exactly. That's what I was just about. I was kind of thinking that we would use something like XYZ dist or PrimUV. I wasn't sure which one it was. Yeah, so we could just not do this and instead flip this. Maybe. And then um sorry, I just try to remember what XYZ dist is exactly here. Yeah, the delay. It's always a thing. Okay. So this is what we want to do. If we take these points like this and we use this, we can. This is actually a pretty not complicated, but if we do XYZ dist, and let's just do an F1 on this. I think that should come up. No, sorry. Let's pull that up. See exactly what it is we're dealing with here. Oh, really? Oh, that's so funny. I didn't even realize that. Thanks. That's good to know. Jeez. I have not used that, apparently. Shows how much production stuff I do these days. Oh, yeah, look at that. Pff, goofy. Dumb me. Thank you for that. Okay. So what I was trying to look up, and this is much smarter, is we've got a source primitive and the source UVs here. So now what we can do is we can take this, and I think I've got a way to get to this. So all right, so we're gonna do a point wrangle here. We're gonna take those and this, and then we can do prim. So do UV W. Okay. So what we should be able to do now is say, let's try this. V at P equals prim UV. Let me pull up the help card just so I don't have to keep referring to this. Don't have these all memorized. Prim UV. So we're gonna do geometry is 0. Attribute name will be P. And then our prim number is going to be, I think, just source prim and source prim UV. Okay, great. So we're going to do welcome back. All right, so let's do, this is going to be I at source prim, and then this will be V at source prim UV, I believe. No, that's not going to work, right? Why is that not working? UVW, is it not reading something? Did I name something wrong? Source prim UV, source prim. I don't know what is happening. There's under something yes. I don't know what yes is too. I must have missed a question somewhere. Oh right. This needs to be 1. There we go. It's like that should work. There we go. And actually, could we do let me just see here. Circle primitive. Could we do this? Copy to points. Oops. Could we do this? Let's just see here. I'll need to get normals and stuff on this, but let's output the P scale here. Okay. Yep. That's looking good. Then if we did normals here, yep, we'll just do that. I think we should just be able to put those right in there, right? I think that'll work. Yep. And then, oh, actually, no, let's put this down here because we can interpolate those normals as well. And have those work out. Okay, let's see here. So yes, because this should, okay, we did that there. Yeah, let's do this. Get off. Do that, like so. Then we can also just calculate a normal over here. I mean, everything isn't a, not everything's Vex, but we're getting pretty close there. Okay, so cool. Then if we take this and interpolate it, kind of do the exact same thing here. Like this. And instead of P, we could do N. We could do via N. That'll keep them stuck to the outside like that. Like that. Okay, cool. And then if we take this, go a bit crazier with it. All right, now we're getting somewhere. Then if we take this and let's say we take the p dot y here of this map. I'm just going to name some of these so we know what the heck's going on here. Then what we could do is we could make, like we were saying, those should get bigger as they go up. And I think we could do that in here. So let's see if we do v at p dot y. So that's going to be looking for just the, oh, sorry. I'm going to make a float from this. Float y position equals v at p dot y. And let's fit that between a certain range here. Not sure how high that goes. So let's say, let's just do a fit 0, 1. I think it's between 0 and 1 right now. So we'll just lock it to 0 and 1. That's fine. And let's just give it, actually, let's call this Y scale instead. I think that'll maybe make a little more sense because we're going to scale it by this much. And so we'll scale it by 1. And this one we can set to 2 for right now. I don't know, that might be too much, but we'll just kind of see what that does. So right now we're basically taking the p.y value here, right? And as it's going up and down, it's going to scale up that y value between 1 and 2. And let's take that and multiply. We should have a p scale on here. And let's take f at p scale times equals this y scale. Let's see if that does it. No, it does not look like it. Oh, is it? Yeah, I think it is. Let me just see here. What if I do this like to like 4, something crazy? Yep, there we go. It is doing it. Lovely. So maybe we do 2.5. Maybe we just leave it at 2. It's kind of working pretty well at 2, actually. Looks pretty good. It's almost, I mean, there's like a little bit of like overlap up at the top there. Yeah, I think we're getting somewhere here. Nice, nice, nice. All right. Well, I mean, I'm going to call that a success. That feels pretty successful. It's feeling pretty good. We could also, if you wanted to, you could also have a ramp there that would control that. So they would scale differently depending on how, they maybe scale faster up to a value of 1 or whatever. Yeah, it's pretty cool. That's a neat little exercise there. Lots of mental sort of things to kind of figure out and jump through there. You could probably avoid overlap at the top with a density value of about a point cloud. Yeah, that's a good point. Yeah, like if they're, well, honestly, a lot of it has to do with how close they are here, right? So like that's the biggest thing. Like they're actually already sort of overlapping here a little bit. So you'd want to like do that a bit more and really kind of crank that a little. And the more stable you can get there, like the better. That's cool. I wasn't really thinking about how that would change that. Interesting. when you instead, I'm just reading what Tom said here. So this is the eyeball approach, but when you instead scatter, get your points from the prim center, probably get the scale from the deformation amount of the primitive. Yeah, you could probably, yeah, I see what you're saying. Yeah, you could calculate right where they are, and you would have to you might do it a little bit different than maybe how I did it, but when you're doing this deformation here, yeah, maybe because it is interesting, right? At the top here, they're not stretching as much. What does his look like? Actually, that's a good question. That is like really clean. I'm actually I'm not. Right. Um just has him further away at the start. Yeah, it could. It could have him further away at the start. Yeah. Let's see here. I don't know. It is interesting because like when in doubt, assume I took the easy path. Nice. Nice. Is there a Vex method that gives you the P scale on deforming geometry? Ooh. You mean like like the area of the primitive? Because like that's kind of what I would think that you would calculate is like the area of each primitive would give you a better P scale value that you could then work with, because then those side ones would be much bigger, the top ones would be a bit smaller, and they would all kind of fit along. But I don't know if there is one actually that does area of a primitive. Don't think there is. I'm just going to go back to this and see. Let's just look for area. That doesn't seem right. That's not anything. Oh, do they really? Good gracious. Should know that. Oh God, that's pretty straightforward then. Yeah, what you would yeah, exactly. Yeah, so what you would do is let's look at the primitives here. Let's take a look at this. I can at least show you what it would be. We won't go into that whole thing. But measured area. I did not even realize that. Good gracious. Oh, amazing. So, yeah, right. So, Walsh is just saying that there would be, because they're stretching non-uniformly, you'd need to derive it from the shortest side, blah, blah, blah. Like there's a lot of stuff happening there. Yeah, for sure. Yeah, you definitely could do some stuff with these intrinsics, I think, maybe. Poorly defined for non-quads. Yeah. Anyways, Yeah, so what you could do there, if you did want to grab the area of those, you could grab this intrinsic here, and I think there's a prim intrinsic function, if I remember correctly. Let's see. Yeah, there you go. So you could read primitive intrinsics that way if you wanted to grab some of that stuff. So there you go. You get the geometry intrinsic name. That you do that in a primitive wrangle and just put in the prim number for it that way. Yeah, for sure. That would definitely give you something a little different. But cool. Well, I think we're gonna call that a success. Don't think it's not perfect, but it's good for a couple hours of screwing around. And yeah, I think hopefully you might have learned something from that if you're new to Vex. Hopefully I didn't hurt your brain too much, but or we didn't hurt your brain too much, because it certainly was not all me. But yeah, so yeah, take a pass at this. Maybe try some other stuff. Take this and go, further with it and see if you can do some of the other stuff. There is also the extended version as well, that I think Stefan had that like going into like a mushroom cap and looked really cool. Have to think about how to do that a little bit. I think you might have like a secondary displacement that gets added to it. My smooth brain now has a wrinkle. Yeah. So I think there's a lot of stuff there that you'd have to kind of play around with. Yeah, I'm certainly not like an expert on Vex or anything like that. Like, I mean, yes, I've done some training on it, but it certainly is more, more introductory stuff that is for getting people up and started and stuff like that. But I use it a bit in production, but like I said, it's been a little bit for me to be in production. So it's nice to do some of this stuff and get my brain back in here and doing some things as well. So yeah, that's great. Yeah. Thanks so much, Code Doggo. That was super nice. Yes, exactly. There you go. Homework is to make that harsh graphic shadowing. Exactly. Yeah, that would be cool. I think like you would probably do something with some sort of a secondary, like having another point that would be a reference for them to look at, basically, from as a light source, like a point light source or something like that. So yeah, try that out. I think that would be pretty cool. I actually am not even sure how I would totally go about it, but yeah, there's definitely some really cool ideas there for sure. Exactly. There we go. So I'm pretty close, at least. So there you go. There's a little something to get you going. Cool. Well, everybody, thank you so much for joining. Definitely a lot of fun. Great to have folks in the chat, maybe some people that I haven't seen before, which is really nice. Always nice to have some new folks around. And yeah, hopefully you learned something. Hopefully we can, we'll see. Maybe we'll do another one of these. This was pretty fun for me, and it's kind of nice this time of year where I'm very busy doing a million things, and it's kind of nice to just have something fun to screw around with. So we'll see what the rest of this comes to, and already for next year, as we're getting close to the end of this year, I've already got some ideas for some things that I might want to try to do, maybe even in January. I've been poked by a few people that are like, "Hey, you should do something," and I think I might give it a shot, but we'll see. I'll have it'll be my Christmas homework. So yeah, thanks everybody for joining. If you're not already on the Discord server, feel free to go to HoudiniHangout.com. There's a Discord link there that you can get an invite, and yeah, join the server. Free for anybody to join. And yeah, it's always nice to have more people in there, just giving people help and advice and things like that. I like to keep it pretty chill place for people to just be there, learn new things. Beginners, people that have been around for a while, anything like that. So yeah, feel free to jump in, add suggestions for future streams. It's always good to know what people are interested in learning about, and for me to learn about too. So yeah, because sometimes you're just like, what can I blow up? What can I melt? Whatever. There's just so many times you can do the same thing. So it's nice to see other people's ideas and stuff. So anyways, thanks everybody for joining. Super nice to get to chat with everybody. And like I said, have some new folks around. And yeah, hope to see you next time. Stream should be next Wednesday at 6 p.m. Eastern Daylight Time. And if you go to the website, it should automatically convert the times to your time zone, hopefully. So, somebody's just yelling from the back. I see. Hi, Matt. Yeah, maybe. Apex next. Yeah, maybe. That may be what I was referencing for January. So we'll see. It's been what? When did I do the Joy of Vex stuff? I think it was 2 years. Was it 2 years ago now? No, maybe it was only one year ago. No, it'll be 2 years in January. That's insane. So yeah. All right, everybody. Have a great night. I'm off to shovel my driveway because I've got snow in it. So have a great night or day or whatever time it is in your neck of the woods. And I'll see you all next time. Have a good one and see you soon. Bye, everybody.